Oh, I didn't apply optimized settings. Oh no. Yeah, whatever. Welcome back. Today I'm just gonna report that I made some progress. So I worked on yucky. So besides these concepts, trying to work out the whole graph for consciousness, I went and tried to figure out how to plot the graph itself. So finally figured out what the quadrant 1 and quadrant 3 should look like and was able to graph it out. So by plotting a 2D animation of a circle in quadrant 1 with equation x minus a, so the equation of a circle is x minus h squared all squared plus y minus a all squared equals r squared, the radius squared of the circle that is being drawn on a coordinate graph. So I took that and made h and k relative to the radius as the midpoint, because that if I'm drawing the circles relative to the timeline x tangent to the timeline x, which is what we will see, what my idea was, what I was mapping out this whole entire time, and that I'm gonna have to keep taking steps further, because I didn't just map out the circle for what exists, but what doesn't exist anymore. And the next few steps are going to involve me basically the difference of circle 2, or no, not the difference. Circle 2 plus circle 1 should equal 1, in the sense that, well, not 1 as the unit number, but technically we're talking about unit squares in terms of the framework, as I'm just going to show you now. Boom. It's that. It's that. Maybe not this exact motion, but it's this. So the animation automatically reverses direction when it reaches. I mean, there's more to this, because when we get from what exists to what doesn't exist, so at the end here, so when existence is basically a dot, it's nothing. This switches over, so quadrant 2, quadrant 3, which, mind you, quadrant 3 in the negative, this is going to be, well, negative I values, complex numbers as well, for 2 and 3, with some, I want to say, basis transitions. I've been refreshing my linear algebra a little bit more, because I know this is all going to be relevant to matrices and eigenvectors, eigenvalues. In fact, the timeline itself is going to be an eigenvector of some sort, because a timeline is just one fundamental thing that we're following. There is one timeline of the universe. The universe, time flows in one direction, right? That's what we're visualizing here in terms of what energy exists in form and what energy doesn't exist in that form anymore. It exists in some other form. In terms of baryonic matter, like atomic matter, okay? Atomic particles, or things with mass energy compared to, let's say, photons, photon field, photon space. Actually, photons in general, we can consider that with luminosity, the max energy value of the Planck scale. So this is where the applications start coming into play. And the whole idea of consciousness and how emergence and divergence works relative to this motion following the timeline X. So I'm going to take this a step further, because point 5, where again we're working with half-life theories, or half-life visualization, understanding, that sort of thing, with also the understanding of bounds. So let's get to quadrant 1 real quick. I could just move the slider. This is cool though too, because when we get about quarter way for both, I mean, the circles should be about equal. That's the half-life, the exact half-life of the universe. So the next factorization that I need to do is not just have the area of circle 1 plus the area of circle 2 equal 1, because again, we're working statistic percentages here from 0 to 1, or eigenvalues from 0 to 1. 0.5 and 1 are, I mean, very relative values in terms of quantum mechanics as well as classical mechanics. When we talk about the EPR paradox, as well as the three transition states that are very clear and obvious, but at the points of intersection from the quantum perspective of field theory versus the real perspective of, well, what we observe physically, what we can interact with physically, because I think that's what differentiates fundamentally, not just as, I mean, the paradox exists because space is space for a reason. Space doesn't interact with us because it's in such a different plane of reality, or a different dimension because it works in fields. To understand like the position of a particle, uncertainty, and everything else is understanding that space itself is clearly a different dimension because it does not interact with us in such a way. Like I'm not touching protons, I'm not having nuclear fission explosions happening while waving my finger around in the air. That doesn't happen. There's not things interacting really that much actively, chemically, with my skin in the air. There may be some nuanced aspects, but overall, I'm not like deteriorating at an accelerated rate, depending on the density of the air or anything like that. So that begs the question of, is the EPR paradox more of a feature rather than a bug, right? I think that's the whole point. Same thing with if you apply electromagnetism to quantum dynamics and you're limited from 0 to 1 in terms of, I think, mass electron volt measurement. Once you get past a certain point, past a certain size, things just don't work in that analyzation anymore. And I think that limit of approaching 1, where things start to get wonky, when exponentials start to really kick in as they shift over, as I mean, the bounds itself, you could check the bounds of what would be quadrant one's bounds. So we take a curve that hugs here and maybe sneaks a little bit behind quadrant one. Maybe there's a little bit of a shift here so that this meets with here. We have a little bit of an offshoot, or maybe it follows quadrant one pretty close. In fact, that really just depends on how far out or in we're zoomed to the circle. We can consider this part as an exponential bound, a lower limit, perhaps, if we have the line here. So let me add the line. Add line y equals x to show the timeline which the midpoint follows along. I'm going to see if this fucks this up or not, because I don't know if my word, this is the thing with using obviously AI tools. If it misunderstands what you're putting in, if it overcomplicates it, okay, good. It did not. Thank you. There we go. Thank you. That's it. That's it. So now you can kind of see what I'm referring to when we talk about our quadrant regions. In fact, set with negative values, if I assign I mean negative I, obviously. Things get very interesting. Because again, with this whole idea, this is a 2D perspective of the 3D reality. How we can measure energy transfer over time, the path of entropy over time. As circle 1 represents the area of, well, energy that exists. If we flattened out basically like a photon thin plane or whatever, or I don't know, just a thin plane of everything, all the matter that existed in space. We lay that all out in one flat area, crunched it with the lower, things that are gonna decay sooner or break down sooner into space, or things that are gonna last longer, like our sun. I mean, our sun lasts pretty long, or certain stars of that magnitude, whereas bigger stars typically don't last as long because they burn out quicker due to density, forcing them to kind of go a little bit faster because of their mass. It's the fact that there's so much concentrated mass in an area, it tells the reactions go more, hence the observed temperature rise. Because I mean, higher temperature leads to more atomic movement. That atomic movement, that interaction, that excitement is going to cause more shit to react, and that's why bigger stars don't last as long as stars like ours. That's, that's one thing. It's relative to the mass too, obviously. I mean, if a star is like super massive, I mean, is dense, but I mean, it's gonna not still not last as long. But maybe once it passes a certain threshold, I think there's like a proportionality to that as well. I don't know too much about cosmology yet, but maybe when I get there. So, understanding that whole principle, what follows the timeline, I mean, this is easy, from 0 to 1, that's the entire timeline, but we can see here when we get to, huh? Oh, because it doesn't tell me a 1 up here. Okay, okay, that's gaslighting the shit out of me. Because there's no point. So, you're gonna have to imagine that this is closer. Is this an easy one? You didn't fucking do it, guy. Excuse me? No. Bitch. Alright, I forget I can zoom that. Okay, well, for visualization purposes, I mean, yeah, it's there. It's there. Don't worry about it. It's there. This box is not accurate to the one value, as you can see that the distance. It's complicated. All right, I don't understand why that is so complicated. Add a marker. It didn't do anything unless it misunderstood what marker meant. Oh my god. Maybe when I learn the code. So the next thing I want to do is be able to connect the area of the circle to the rate of change, like the rate of motion rather of the midpoint. So I mean, obviously, the speed at which it grows or shrinks depends on how much of it exists or how much of it doesn't exist. That's when there's less things to interact in space, less likely to have things happen. There's more distance between things, things become more isolated. Then, I mean, time can seemingly flow in one direction without you realizing what's going on around you, and everything could be ending around you, or it could just be I don't know, you're a speck of dust in the whole grand scheme of things. Who knows? That is also another interesting tidbit too, because when we see stars in space, there's a lag of light years because light has a speed limit, and depending on how far the thing is, star is, celestial body, whatever is being observed, is a little bit offset. I mean, we're seeing the past because of that lag. We're seeing old light that is now reaching us. So we're not seeing the now. We don't know exactly like the proportionality from what's going on over there compared to what's going on where we are. What the actual timeline really is in the grand scheme of things or locally. So this is why this framework should be able to be applied both on, a small basis and a large basis using at least what we have so far with the equation. Now going back to both axes. You didn't. It's all shown in bold. You didn't do anything. You lying piece of shit. You didn't. Unless is that it? No. No, you didn't. You didn't. You liar. Bro. That I don't see it. You put .5 and 00. You didn't put no numbers. Bro. Yeah, I think this whole concept of consciousness just keeps breaking all these AIs. Oh, man. I mean, understandably so, it should, but. No, go away. Screw you, I don't like you. Did you already auto delete? You gone? Bye. Bye bye. Back to what I was doing. So, yeah, I wanna. This is what I gotta figure out is having the area of a radius 1 circle be relative to the pace, the rate of change of its area. It's a feedback loop. I mean, yeah, that's kind of what life is anyways. It's a feedback loop, action, reaction. So if circle 1 plus circle 2, the areas equal 1, or, well, 1 being the area of one circle, right? That's what I say by it being equal to 1. I mean, again, if we had our square here, technically, yes, it should be equal to 1. Obviously, the area is not going to be equal to that, but the radius squared, rather, because, but that wouldn't be the radius squared. That would be 0.25, which is, I mean, pi over 4. So it's a factor of, I know it's a factor of pi over 2. It's going to be relative to this. But pi over 4 is the area. And that is close to 1. Actually, whoa. Yeah, because some people used to think that pi. Oh yeah. Oh no, now I see that. Yeah, because that's. Oh, okay. So pi over 4. I mean, a square is 4 sides, but that wouldn't be the area. The area would be 1. But pi itself is a number. It's close to 1 because it's a little less than 1, right? And obviously, if it was the square was there, 1 times 1 would be 1. So that's why the area of one circle, I mean, that would be pi over 4, so that means those equations technically would be that. But I'd have to get r squared onto one side. I'm just trying to think of it in my head, kind of, so it makes sense. Oops. Because, I mean, the equation of a circle, again, we're using a instead of r. I mean, a is relative to everything here. It's relative to the radius, its motion, its midpoint, all of that, all tied. So if we have x minus a squared plus y minus a squared equals a squared with a limit from 0 to 1/2, area being pi over 4. Hmm. Because the total between both would be pi over 4. But that would mean if I wanted the equation for this circle plus that one to equal not just r squared, because I have to have it equal to 1. And obviously they're both differences of each other. So I have to, this is where the math gets complicated, because I have to equal these equations. I have to move the circle 2, I have to move a max minus a squared over to this side by dividing it, make it equal to 1. So I divide both sides by a max minus a to the power of 2, which, I mean, would factor out that for some aspects it would leave what, x squared and y squared, and also a little bit of a mess in between, but it would be equal to 1. And then I have to do the same thing with the a squared, which that one is going to be what, x squared plus y squared plus ax plus yx, something like that, or minus, actually, because of the negative sign. Okay, equals to 1. And so, since that's going to be differences here, if this plus this must equal 1, and 1 being the area of a circle, so pi over 4, then maybe I can do that. If I can tie the motion of the radius to the area that way. I'm going to ask Claude and see what it can do first. But this is at least what I'm thinking of how to do it. This is why I need to work out the equation. Because if I can get that rate, it might be relative to Euler's equation, I'm pretty sure. Um, hmm. 2. So apply the rate of change of the areas. The total of the areas of circle 1 and 2 relative to being pi over 4 relative to the midpoints motion along timeline y equals x. Curious. It's doing a lot of thinking. Um, I broke it. Um, holy shit. Seizure warning? What the fuck? Slower, slower. That's. I feel like that's more correct. Like, whatever the fuck that is. But what? Hmm. Try that. Because I feel like this kind of animates it pretty well. Kinda. The flashing back and forth, I definitely fuck something up. That's very interesting. That just does that. Hmm. I wonder if it can pick up the deceleration. Nope. Oh wait. Huh. All right, I want to see what this does. Doing some, I guess, vibe coding. Eh, curious. Oh, okay. Interesting. Oh, yep. Yeah, there we go. See how that slows down? There we go. Once it gets to the midpoint, and then speeds up. Ooh, there it is. So it's moving like an exponential function. Because as it, the acceleration at a certain point, and it gets to here, slows down, slows down, slows down. Probably once it gets to a quarter, then it starts speeding back up, speeding back up. So I move much faster than it's moving, but you can kind of get the gist of it. So my question is, how did it do that? Because that is basically what I had in mind. Now the only thing is, obviously, the real timeline is of existence is only quadrant one, or the existence of forms of mass energy at the end of the day, because that's matter. That's what matters, right? Doesn't exist as in a form of mass energy. If it's just photons, then it's just space at that point, or just neutrinos, or well, whatever ends up at the end of time. We still haven't come to a conclusion on that yet, but I mean, suggestions say either photons or neutrinos or both, something like that. Probably does end up turning into photons. We don't know. What we do know is statistical math, and with how relativity works, how bounds and certain things that exist within the universe, how they flow, the relative factors, we see patterns, and these patterns apply to a lot of different things. Maybe not always one to one. Again, this is to be used in the context of whether energy or just it's a dichotomy. It's of opposites. It's, I mean, what matters is what we can interact with. What doesn't matter, what doesn't exist, is what we don't interact with. Right? That's the measure. And we have possibility and impossibility. That's going to be the inverse of what's going to fall along. And similarly to this, so I haven't got those equations yet either, but they should also be here. And then this is going to be the the change in possibility, probability, line of probability. how possible something is to occur. That's probability. How probable it is. So both of these can be modeled onto a 2D graph like this. And we can take this model and fill in for the different variables. So my understanding of coding is not that good, but export default function, inverse circles animation, yep. Constraint, use state 0, is animating, set is animating, use state true, yep. Direction 1, pi, so it's the scales, the different values. If animating, return that. It's not that much code either, which is good. But it is re-importing what I already did. Oh, and the effect react. So that must be the animation program that it uses. Inverse circles animation, yada yada. Didn't say which version, it just kind of went off the basis. Straight interval, set previous to that. Calculate current areas. Boom, 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 boom. String, calculate rate of change for each circle. So area 1 minus previous area 1. Area 2 minus previous area 2. The rate of change, or the derivative. Interesting. Total area should equal pi over 4, correct? So it's modeling, yes, correctly. Constraint, base step 0. So base step size. So this is, I mean, how quickly it's going. If I change the step size, then obviously it'll move faster. Okay. Area deviation. Math. Current total area minus target total area. Proportionality factor 1 to 1. Area deviation. Deceleration 1 to 1. Plus area change rate times 20 or to the power times 20. Interesting. Acceleration 2. So that's of what, circle 2? Area change rate of circle 2. Individual deceleration based on circle's rate of change. Higher rate of change equals more deceleration. Resistance to change. Interesting how it interpreted that. Okay. That's interesting. Higher rate of change equals more deceleration. So it's like parabolas underneath and not necessarily. Oh, well, yeah, it's not even just exponential function, it's a parabola at that point. That's underneath. Oh, yeah. Huh. Interesting. Combined deceleration factor. Yeah, because the derivative under that would be probably a parabola underneath the midpoint. Or superimposed underneath the midpoint, kind of. I don't know, superimposed underneath the midpoint of the timeline relative to from 0 to 1. Hmm. Hmm. That's interesting. Let's see if I can see what I'm thinking. So it's slow, so it's like parabola. Slows up to the top, kind of, and speeds back up after this point. Definitely is a slow rise, and then. Oh, that's quick, yeah. Huh. No, it's pretty. Well, it slows down, and then speeds up pretty quickly there. That's very interesting. Hmm. I don't think the model is really correct with what I was thinking, but this is an interesting model nonetheless. So I think maybe the rate of change, I don't know. Because like once it gets that past that point, just mm, it's a slow lull toward the middle. Well, I mean that seems constant. Hmm. Because that would be the perceived deceleration, and then it's pretty constant. The circumference itself, though, is slowing down, slows down there. I don't know. I need to look at the numbers too. Oh, that speeds the fuck up. Holy shit. No, that is exponential. That's speeding up. Holy shit. And then when the area approaches, so visually it's hard to see it because I mean, as the circle grows, the other one gets smaller. It's hard to perceive the deceleration of the area itself or the acceleration of the area when it grows up to that, which I mean, very interesting because I feel like this was like relative to like a Planck moment in time, like a Planck timeline, and the motion across that, or the distribution of energy over that time in space relative to the Big Bang. It gets that little jolt right there at the end. It's so weird. No one does it there. It's, oh man, I don't know. I don't know. But this is at least what I'm. This is more what I was envisioning, for sure. And this is why, at least now, I got the equation for circles down and how to do two concentric circles with changing area following a timeline, like I initially thought of. And I gotta add more, so maybe next time. But this is at least what I got so far. I'm gonna work more of this out and continue fleshing out a model that should at least, yeah, the display now shows circle in its individual rate of change. Motion along the timeline becomes more nuanced as each circle's contribution to the overall movement is proportional to its own area dynamics rather than the combined total. That is interesting because I mean that also makes sense. I mean, in terms of like its own area dynamics, existence relies on itself to interact with itself. So, oh man, it's interesting model in this type of shit. And like it goes faster that way, kind of fast down, slows down, Yeah, that's time dilation. 'Cause see, initially it seems like it's going pretty fast, and it slows down, going along the timeline as it should. Once it gets past this point, it is moving slow. It just because the circle and perspective is getting smaller faster because there's a lot less going on. Oh man. And then the acceleration of space itself is basically right here. Kind of like a slow lull, and then at the very end, as whatever's able to interact, whatever's left decaying is decayed. So at that point, everything's either localized or spread out in such a way where that just works. I don't know, but I'm gonna look more into this. Is interesting shit. Anyways, until next time, this is Spark saying peace and fuck you bots. Holy crap. Cat. Meow. God damn. Alright, night.